Yes, namaste to all. Welcome to the online classes. So in the last lecture we discussed problems based on the definite integrals. Okay, that means by using fundamental theorem of the calculus we solve some of the problems. Okay, so today's class let us again start with the problems. Okay, some more problems are there. We'll discuss those problems and then we'll move to the properties of the definite integrals. The properties are very important. Okay. Yes. Before that, so write down problems. So continue with the previous classes. These problems. Okay. Yes. So write down first one. Evaluate the integral from 0 to 1 x divided by x square plus 1 into dx. Okay, evaluate the integral from 0 to 1 x divided by x square plus 1 into dx. A solution. So given integral I which is equals to from 0 to 1 x divided by x square plus 1 into dx. So how to find the antiderivative of integrand x divided by x square plus 1. Okay. So here we need to use the substitution method. Here put x square plus 1 is equals to some variable say t. Okay, and solve it. So put x square plus 1 is equals to t. Now differentiating this x square plus 1 with respect to t. So derivative of x square is 2x into dx is equals to dt. Okay, and see here only numerator x into dx is there. So write down this 2x into dx dt as x into dx, which is equals to take to this side. So that is dt divided by 2. Okay. So in place of x into dx we will substitute, that is dt by 2, and in place of x square plus 1 t. And simultaneously limits of the integration also changes. So when x is equals to 0, then t is equals to 1. When x is equal to 1, that is 1 plus 1, 2. That is t equals to 2. Okay. Yes. So here t is equals to x square plus 1. When x is equals to 0, then t is equals to 0 plus 1, that is 1. When x is equals to 1, t is equals to 1 plus 1 square plus 1, which is equals to 2. So now lower limit is 1 and upper limit is 2. So substitute these things in the integral I. So integral I reduces to which is equals to integral from, so x into dx is dt by 2. So dt divided by 2. So 1 divided by x square plus 1 is, so 1 by x square plus 1 is, that is t, 1 by t. So lower limit is 1 and upper limit is 2. S, which is equals to integration of 1 by t, that is log of modulus of t. Okay. Yes. From 1 to 2. So here 1 by 2, that means dt divided by 2 is there, na? So 2 is constant. Take outside the integral, that is 1 by 2 into log of mod t 1 to 2. So which is equals to 1 by 2. Yes, by using fundamental theorem of the calculus. So substitute in place of t, upper limit, that is 2. So log of modulus of 2 minus log of modulus of 1. Okay, equals to 1 by 2 times of log of modulus of 2. So log of 1 value is 0. So leave it 1 by 2 log 2, which is equals to log of root 2. Because 1 by 2 log 2 can be written as log of 2 to the power 1 by 2. That is n into log n property. Okay. So here n of log n is equals to log of m to the power n. So that 1 by 2 log 2 can be written as log of 2 to the power 1 by 2. 2 to the power 1 by 2 means that is root 2. Okay. Yes. So here we used the substitution method to solve this definite integral along with the fundamental theorem of the calculus. Okay. Yes. So next problem. Second one, evaluate the integral from 0 to 1 x into square root of x plus 1 into dx. Okay, evaluate the integral from 0 to 1 x into square root of x plus 1 into dx. Wait a minute. Instead of okay. Solution. So integral I from 0 to 1 x into square root of x plus 1 into dx. Okay. So substitute in place of x plus 1, that is in place of x plus 1 t square. Okay. Substitute in place of x plus 1 is t square or some variable in it. Okay. So here put x plus 1 which is equals to t square. Now differentiate this x plus 1 with respect to t. So what you will get actually, that is dx which is equals to derivative of t square with respect to t is 2t into dt. Okay. So dx is equals to 2t into dt. As x plus 1 is equals to t square, which implies x is equals to t square. So take this plus 1 to this side, that is minus 1. Okay, x plus 1 is equals to t square, then x is equals to t square minus 1. This is because we need to substitute in place of x is t square minus 1, and here square root of x plus 1. In place of x plus 1 is t square, and in place of dx is 2t dt. Okay. Yes, simultaneously again limits of the integral also changes. Okay. So here t square is equals to x plus 1. So here when x is equals to 0, then t square is equals to 0 plus 1. 0 plus 1 is, that is 1. T square is equals to 1. Similarly, when x is equals to upper limit, that is 1, then t is equals to that is t square is equals to 1 plus 1, that is 2. So which implies t is equals to root 2. So upper limit is root 2 and lower limit is 1. Substitute these things in the integral I. So then it reduces to or changes to integral from, in place of x is t square minus 1. So t square minus 1 into, in place of square root of x plus 1. X plus 1 is t square. S into dx can be written as here 2t dt. Okay, dx is 2 into t into dt. S. So lower limit is 1 and upper limit is root 2. S, which is equals to, now integral from 1 to root 2 t square minus 1. Root of t square is t. Correct na? Square root get cancelled. T into 2t. T into 2t is, that is 2t square. So I will write this 2 outside the integral, and here t square into dt. This t square is because of here square root of t square is nothing but t. T into 2t, that is 2t square. So we will take the constant 2 outside the integral here. So remaining is t square into dt. Now equals to s, keep 2 as it is, integral from 1 to 2, multiply t square, that is t to the power 4 minus t square into dt. Okay, s. Now integrate this t raised to 4 with respect to t and t square with respect to t. S equals to 2 times of, this is square root of 2 na? Yes. Integration of integration of t to the power 4 is, that is t to the power 5 divided by 5 minus integration of t square is, that is t cube divided by 3. Yes. So from 1 to root 2. Okay. Now use the fundamental theorem of the calculus. First substitute upper limit root 2 in place of t and minus of in place of t substitute 1. Okay. S equals to keep to as it is S. So first substitute upper limit, that is root 2 in place of t. So t root 2 whole raised to 5. Okay. Root 2 whole to the power 5 divided by 5 minus root 2 whole cube divided by 3. Okay. Minus in place of t again substitute lower limit, that is 1. So 1 raised to 5 is 1. 1 divided by 5 minus 1 by 3. 1 by 5 minus 1. Okay. Yes. Now just simplify this. Root 2 whole raised to 5 can be written as root 2 whole to the power 4. Correct? Huh? So integral I, which is equals to 2 times of root 2 whole to the power 4 into root 2. Root 2 whole to the power 4 is, see, root 2 whole to the power 4 into root 2. So this is actually 2 square. 2 square is 4. 4 root 2 na? Yes. So this can be written as 4 root 2 minus this root 2 whole cube is root 2 whole square into root 2. Root 2 whole square is, that is 2 root 2. Here 4 root 2 minus 2 root. Okay. Yes. So 4 root 2 divided by 5 minus 2 root 2 divided by 3. Next here, minus into 1 by 5. Yes, just simplify. 1 by 5 minus 1 by 3. So LCM is 15. Here 3 minus 5. So 3 minus 5 is minus 2. Minus 2 divided by 15. So here write down minus of minus 2 divided by minus of here minus 2 divided by 15. So minus of minus plus 2 divided by 15. Okay. Just see here outside minus is there. So here LCM is 15. Okay. So 15 means here we need to multiply with the 3. Here 5. So 3 minus 5 is minus 2. Minus 2 divided by 15. So minus of minus is plus 2 divided by 15. Okay. Yes. So now which is equals to 2 times of, now LCM is 15. Okay. Yes. So here we need to multiply with 3. So 3 4s are 12 root 2 minus here we need to multiply with the 5. 5 2s are 10 root 2 plus here 2. So which is equals to 2 times of 12 root 2 minus 10 root 2, that is 2 root 2 plus 2 divided by 15. So just multiply 2 inside or take 2 common. So after taking 2, that is 2 2s are 4 root 2 plus 1 divided by 15. So this is the answer. Okay. Here initially we need to substitute x plus 1 is equals to t squared. Okay. And simplify we will get the result. Yes. Pause ಮಾಡ್ಕೊಂಡು ಬರ್ಕೋಬೇಕಾಗಿ. Okay. Yes. Then next question is third question. Evaluate integral from minus 1 to 1. Evaluate integral from minus 1 to 1 divided by x square plus 2x plus 5 into dx. Okay. Evaluate integral from minus 1 to 1 divided by x square plus 2x plus 5. So here given integrand is in the rational form. Okay. That means we need to find the antiderivative of this integrand by using the partial fraction method. Okay. Or if in denominator it is in the form of a perfect linear factors or some square of the factors or repeated factors, then definitely we will use the partial fraction method. Is it possible to write this is in the perfect square? X square plus 2x plus 5? No. So we need to use the squaring method. Okay, and make this into the perfect square method and solve it. Yes. Yes. So here solution, given integral I from minus 1 to 1 divided by x square plus 2x plus 5 into dx. Okay, so here see, first observe the coefficient of x square. Coefficient of x square is 1 is there, so definitely we can apply. Then coefficient of x is 2 is there, so of it what we will get, that is 2 by 2 is equals to 1, and square it, 1 square is equals to 1. So we need to add plus 1 and subtract 1. Okay, so x square plus 2x plus 5 can be written as from minus 1 to 1 divided by x square plus 2x plus 1 plus 5 minus 1. Okay, yes. Which is equals to integral from minus 1 to 1 divided by this x square plus 2x plus 1 can be written as x plus 1 whole square plus 5 minus 1 is, that is 4 into dx. Then next, now integral I, which is equals to integration from minus 1 to 1 or integration from minus 1 to 1 divided by x plus 1 whole square into 4 can be written as 2 square dx. So this is of the form, see, integration of 1 divided by x square plus a square. Correct? Not directly use formula, that is x square plus a square, or we go by the substitution method also. Okay, yes. So here substitute in place of x plus 1 is t. So put x plus 1 is equals to t. So if x plus 1 is equals to t, then derivative of x with respect to t is dx is equals to dt. So definitely lower and upper limit also changes. So when x is equals to minus 1, when x is equals to minus 1, then t is equals to 0. When x is equals to upper limit 1, then t is equals to 2. So from 0 to 2, upper limit is 2 and lower limit is 0. So then definitely integral I from 0 to 2, here dx can be replaced by dt divided by x plus 1 is t, so t square plus 2 square. Okay, now this is of the form integration from 0 to 2, 1 divided by t square plus a square, that is 1 by x square plus a square. So 1 by x square plus a square can be written as 1 by a tan inverse of x by a. Okay, so here variable is t is there. So this can be written as 1 by a, here a is 2. 1 by 2 tan inverse of x by a, here variable is t is there, t divided by a is 2. Yes. So limits from lower limit is 0, upper limit is 2. Yes, now integral I is equals to, write down 1 by 2 as t. Now use the theorem, that means first substitute upper limit in place of t and minus lower limit. So 1 by 2 tan inverse of, so t in place of t substitute 2, so 2 divided by 2, that is 1 minus tan inverse of 0. Okay, yes. So 1 by 2 tan inverse of 1 is pi by 4 minus tan inverse of 0, 0. So now answer is pi by 4 into 1 by 2, that is pi divided by 8. So value of the integral is pi by 8. Okay. Yes. Now we will move with the properties of definite integrals. Okay. So these properties of definite integrals are very important. So totally there are 8 properties are there. Okay. These properties are helps us to solve directly definite integral problems. Okay, without simplifying and those things. Just by seeing whether given definite integral in the form of either one of the form, then we can say we can use these properties. Okay, that means these properties will help us to solve the problems easily. Okay, ಇವುಗಳನ್ನೆಲ್ಲ ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ 8 properties are. Okay, yes. See here, first one, property number 1. So integration of a to b f of x dx is same as, which is equals to a to b, integration of a to b f of t into dt. That means, so changing the variable in the integrals, changing the variable in the definite integral, so value of the integral does not changes. That means integration of sin x, for example, integration of sin x dx from 0 to pi is same as integration of 0 to pi sin t into dt. Both are already same. See, just I change the variable x to t. ಅರ್ಥ ಆಯ್ತು. ಎಕ್ಸ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಟಿ ಬರ್ತಿದ್ದೀನಿ, ಯಾವುದೋ ಒಂದು ವೇರಿಯಬಲ್ ತಗೊಂಡಿದ್ದೀನಿ. ಸೊ ತಗೊಂಡಾಗಲೂ ಕೂಡ ಸೊ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿ ಇಂಟಗ್ರಲ್ ಡಸ್ ನಾಟ್ ಚೇಂಜಸ್. ದಟ್ ಮೀನ್ಸ್ ಅನ್ಅಲ್ಟರ್ಡ್. Okay, so first one, property number 1, which says that the value of the integral does not changes when variable changes. That means your integration of a to b f of x into dx is same as integration of a to b f of t dt, again which is same as integration of a to b f of z dt or f of a into dA, f of z into z dz and so. So that is property number 1, integration of value of the integral does not changes when variable changes. Then next, property number 2, the value of the integral changes, the value of the integral changes when limit of the integration is interchangeable. See here, integration of a to b f of x into dx, which is equal to minus of, that means negative of the integral from b to a f of x dx. See, observe what is it? Here a to b, but here b to a. That means here lower limit is a, upper limit is b. Here lower limit is b, upper limit is a. That means integrals, that means limit of the integration is interchange. ಚೇಂಜ್ ಮಾಡಿಕೊಂಡಾಗ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿ ಇಂಟಗ್ರಲ್ ಅಲ್ಲಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಯಾವ ರೀತಿ? ಇನ್ ದೇರ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್. ದಟ್ ಮೀನ್ಸ್ ಮೈನಸ್ ಬರುತ್ತೆ, ಮೈನಸ್ ಆಫ್. ಓಕೆ, ಸೊ ಇಂಟಿಗ್ರೇಷನ್ ಫ್ರಮ್ a to b f of x into dx, which is same as the minus of b to a f of x dx. First one, the value of the integral does not changes when variable changes. Second one, the value of the integral changes by its sign when limit of the integration is interchangeable. Third one, property number 3, integration from a to b f of x into dx, which can be written as, which is equals to integration from a to c f of x into dx plus integration from c to a c to d. Wait a minute, not c to a, here a to c, c to b. Okay, integration from a to b f of x into dx, which is equals to integration from a to c f of x dx plus c to b f of x into dx. That means the interval ab is there na, so this can be divided into the, or we can split the interval into a to c, c to b. Interval ಏನಿದೆ a to b ಇದೆ, so ಇದನ್ನ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಯಾವ ರೀತಿಯಿಂದ? A to C, one interval. Next one is that is C to again B. So here integration from A to B, which is same as the sum of the integral from A to C and plus C to B. Okay? Yes. ಅಂದ್ರೆ ಇಂಟರ್ವಲ್ ನ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು. ಸಪೋಸ್ 1 to 5 ಇದ್ರೆ 1 to 3 ಇದ್ರೆ ಇದನ್ನ ಯಾವ ರೀತಿ ಬರೀಬಹುದು? ಇಂಟಿಗ್ರೇಷನ್ ಫ್ರಮ್ 1 to 3 ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ ಇಂಟಿಗ್ರೇಷನ್ ಫ್ರಮ್ 1 to 2 ಪ್ಲಸ್ 2 to 3. ಇದು ಥರ್ಡ್. Next, property number 4. So here integration from A to B f of x into dx, which is equals to integration from A to B f of a plus b minus x into dx. These two are one and the same. See, property number 4 is very important. Integration from A to B f of x into dx is equals to A to B f of a plus b minus x into dx. Next, property number 5. If suppose integration from 0 to a f of x into dx, which is equals to integration from 0 to a f of a minus x into dx. Property number 5 is the particular case of the property number 4. That means take a is equals to 0 here. In property number 4, take a is equals to 0 and b is equal to a. So we will get the property number 5. Both are on the same. So this is the special case of this property number 4. Okay, this is also very important when solving these 3D problems. 0 to a f of x into dx, 0 to a f of a minus x into dx. Next, property number 6. Integration from 0 to 2a f of x into dx, which can be written as 0 to a f of x into dx plus 0 to a f of 2a minus x into dx. Next, property number 7, 0 to 2a f of x into dx, which is equals to if f of 2a minus x, if f of 2a minus x is equals to f of x, then integration from 0 to 2a f of x dx is 2 times of 0 to a f of x dx. This property number 7 is the special case of property number 6. See, observe here. 0 to 2a f of x into dx, which is equals to 0 to a f of x into dx. If suppose in place of f of 2a minus x, if suppose f of 2a minus x is equal to f of x, f of 2a minus x is equal to f of x, then this is also 0 to a f of x into dx. So that means these two are both are same. That means just add these two terms, we will get the 2 times of 0 to a f of x into dx. Goda property number 6 ಏನಿದೆ ಅಲ್ಲ, ಈ 6 ಇಂದ 7 ಅನ್ನು ಡಿರೈವ್ ಮಾಡಿ. ಈ ಸೆಕೆಂಡ್ ಇಂಟೆಗ್ರಲ್ ಇಲ್ಲಿ ಇದೆ. So here f of 2a minus x, if it is equal to f of x, then integration from 0 to a f of x plus integration from 0 to a f of x. Just add ಮಾಡ್ಕೊಂಡ್ರೆ 2 times. Next, if suppose this f of 2a minus x is equal to minus f of x ಆದರೆ these two are opposite. ಅಂದ್ರೆ ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ನಮಗೆ ಏನು ಬರುತ್ತೆ? 0. ಅಂದ್ರೆ ಪ್ರಾಪರ್ಟಿ ನಂಬರ್ 6 ಇಂದ ನಮಗೆ ಪ್ರಾಪರ್ಟಿ ನಂಬರ್ 7 ಬರುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಪ್ರಾಪರ್ಟಿ ನಂಬರ್ 6 ನ ಇಟ್ಕೊಂಡು ಈಸಿಲಿ 7 ನ ಬರಿ. ಸೊ ದೆನ್ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ನಂಬರ್ 8 is integration from minus a to a f of x into dx, which is equals to 2 times of 0 to a f of x into dx when or if f of minus x is equal to f of x. F of minus x is equal to f of x means when function is even. F of minus x is equal to f of x means when function is even, then integration from minus a to a f of x dx can be written as 2 times of 0 to a f of x into dx. If function is odd, then the value of the integral is 0. So that is minus a to a f of x into dx is equals to 0. Okay, so these 8 properties are very important, and again we will solve, we will give the proofs for these 8 properties. Okay, yes. Yes. Now we will see the proofs of those 8 integrals. Okay, again properties adavalla avadu proof nodona one by one. Okay, yes. So first one, property number 1. Okay, so here is property number 1, that is integration from a to b f of x into dx, which is equals to integration from a to b f of t into dt. That means the value of the integral and are same when variable is changed. Okay. Yes. So proof. Easy proof for this one. Okay. So that means see, consider the left hand side LHS, that is integration from a to b f of x into dx. So change the, or here substitute x is equals to t. X is equals to t, that means we need to differentiate x with respect to t. So what you will get, that is dx is equals to dt. Okay. When x is equals to a, when x is equals to a, then t is equals to a. When x is equals to b, then t is equals to b. So that means lower and upper limit also same. When we change the variable, okay, so which is equals to integration from a to b f of x in place of x t take into dx can be written as dt. Okay, so this is our LHS. So conclusion is integration from a to b f of x into dx, which is same as the integration from a to b f of t into dt. So now here LHS, which is equals to RHS. So this is the proof of the property number 1. Then second property, that is the value of the integral changes when the limits of the integration is interchanged. Okay. So property number 2. Okay, pause ಮಾಡಿ copy ಮಾಡ್ಕೊಳ್ಬೇಕು proof. Okay. Yes. Now property number 2, that is integration from a to b f of x into dx, which is equals to minus of integration from b to a f of x into dx. When limits of the integration is interchanged, then the value of the integral changes by its sign. Okay, negative. Okay, yes. Proof. Let capital F of x be an antiderivative of f of x. Okay, here capital F of x be an antiderivative of integrand f of x. Now, so LHS, or just take the integration from a to b f of x dx, which is equals to, see, by using fundamental theorem of the calculus, how to write this one, integration of a to b f of x into dx. Here capital F of x is the antiderivative. Then we can write this, which is equals to f of b minus f of a ಅಂತ ಬರೆಯಬಹುದಾ? So f of b minus f of a. This is by the fundamental theorem of the integral calculus. Okay. Yes. Now which is equals to, now I will take the minus sign common from this. So now this can be written as f of a minus f of b. Okay. Yes. Which is equals to, see, here upper limit is b, lower limit is a. So that this can be written as a to b f of x into dx. Okay. F of b minus f of a can be written as a to b f of x into dx. First time bandidella, this is upper limit, this is the lower limit. So similarly, minus of f of a minus f of b can be written as, so now upper limit is a, lower limit is b. So this is nothing but integration from b to a f of x into dx. Okay, so here integration from a to b f of x into dx, which is equals to minus of b to a f of x into dx. So this is the proof. Just a simple, bala simple. ಏನili capital F of x be the antiderivative of f of x ಅಂತ ಹೋಗಬೇಕು. So this is by the fundamental theorem of the calculus. This is by the fundamental theorem Theorem of integral calculus. Okay. Yes. So by the fundamental theorem of the integral calculus, a to b f of x into dx equals to f of b minus f of x. So this is the proof of the property number 2. Next, property number 3. Proof so bhala simple adavadi. Just we will prove by using the definitions or by theorem. Okay. ಯಾವ theorem? Fundamental theorem of the integral calculus statement ಇದೆಯಲ್ಲ ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಪ್ರೂವ್ ಮಾಡಬಹುದು. Next, property number 3, that is integration from property number 3, integration of a to b f of x into dx, which is equals to integration from a to c f of x into dx plus integration from c to a f of x into dx. ಅಂದ್ರೆ ಇಂಟರ್ವಲ್ ನ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ. a to b ಇದನ್ನ a to c plus c. Yes. Proof. Let capital F of x be an antiderivative of f of x Now see, I will take the RHS part first and I will prove the LHS. Okay, so RHS, which is given a to c f of x into dx plus integral from c to a f of x into dx, so which is equals to c. The antiderivative of this f of x is capital F of x. Okay, so that by using the fundamental theorem of the calculus, how to write this integration from a to c f of x into dx means, so this can be written as f of capital F is antiderivative of f of upper limit, here upper limit is c, minus f of lower limit is a. Okay, so this is by the definition, by the theorem, that is fundamental theorem of the calculus, integral calculus. Plus here again apply the fundamental theorem of the calculus, that is f of upper limit is a minus f of lower limit is c. Okay, difference of the value of the antiderivative at the upper limit and at the lower limit. Difference of the value of the antiderivative at the upper limit as well as at the lower limit. Yes, now see here plus f of c, here minus f of c get cancelled. So remaining minus f of a plus f of wait a minute. Yes, minus wait. So actually this has been a interval is a to b is there. Okay, interval from a to b f of x dx. So that is a to c plus c to b. So that here you need to take b. So this is f of b minus f of a. Okay, yes. So now minus f of a plus f of b can be written as f of b minus f of a. So how to write this one? By using the definition or theorem of the fundamental theorem of calculus. So f of b minus f of a can be written as, which is equals to integral from a to b f of x into dx. So this is our left hand side LHS. Okay, so that first we need to consider right hand side part, that is a to c f of x dx plus c to b f of x into dx. So by using fundamental theorem of the calculus, this integral can be written as difference of the antiderivative at the value of the antiderivative at the upper limit and at the lower limit. So your upper limit is c there, so f of c, lower limit is a f of a, plus here again value of the antiderivative at the upper limit of b and at the lower limit is c. So cancel the term, so ಉಳಿಯೋದು f of b minus f of a. ಇದನ್ನ ಯಾವ ರೀತಿ ಬರೆಯಬಹುದು? again a to b f of x. So this is the now here RHS, which is equals to LHS. Okay, hence proof. This is property number 3. Then property number 4. Okay. So now next property, that is property number 4. So a to b f of x into dx, which is equals to a to b f of a plus b minus x. Okay, f of a plus b minus x into dx. So proof, write down. So proof. So here consider the left hand side, that is LHS a to b f of x into dx. We will prove by using substitution method. Okay, a to b f of x into dx. So here put or substitute x is equals to a plus b minus t. A plus b, here x is there, just to substitute in place of x is a plus b minus t. Okay, here a and b are numbers, t is a variable. If a plus b minus t, then differentiate this x with respect to t. So now we will get the dx is equals to, so dx is equals to a and b are constant, derivative is 0, minus derivative of t is dt. So dx is equal to minus dt and x is equals to a plus b minus t. So here we are using substitution method, means definitely limits also changes. So see, when x is equals to a, when x is equals to a is equals to a plus b minus t, correct? When x is equals to a is equal to a plus b minus t. A get cancelled, then b minus t is equal to 0, then t equal to b. So when x is equals to a, then a is equals to a plus b minus t. So which implies t is equals to, here a get cancelled, remaining t is equals to b. So when x is equals to b, then b is equals to a plus b minus t, which implies t is equals to e. Okay. So here when x is equals to a, then t is equal to b. When x is equals to b, t is equals to a. Substitute these things in the LHS. Okay. So now, which is that LHS reduces to integration of f of, in place of x substitute a plus b minus t into, in place of dx is, that is minus dt. Okay, so minus dt is, lower limit is, that is b, and upper limit is a. So now LHS, which is equals to, see here minus sign is there, minus dt. So take outside the integral, that is minus of a to b, sorry, minus of b to a, f of a plus b minus t into dt. Okay, yes. Here use the property number 2. That means just interchange the limits of the integration. So here b to a is there. So I will take a to b, then sign of the integral changes. Here minus is there. So here it will becomes plus f of a plus b minus t into dt. So here we need to mention, that is property number, property 2. Okay, since the property number 2. Now which is equals to integration from a to b, f of a plus b minus, in place of t I will write x. Okay, a plus b minus x into dx. That means I change the variable t to x, then definitely the value of the integral does not changes, because again property number 1. So again here, since property number 1, okay, here we are using the property number 1. Okay, that means t changes to x. So this is our RHS. Okay, so which is equals to right hand side expression. So that, so conclusion, LHS is equals to RHS. That means integration from a to b, f of x into dx is equals to integration from a to b, f of a plus b minus x into dx. So this is the proof of the property number 4. Okay? Yes. So remaining 4 properties are there. So we'll discuss in the next class. Total 8 properties are there. Okay na? So these properties are important. Proofs also important. Yes. Thank you. Thank you all.